Hi guys, I'm Srikanth.
Hello, I am Felix Francis.
Hi, this is Kali.
Hi, this is Pradeep.
Hi friends, here we are going to introduce an online open source tool for modeling and simulation purposes. For all the systems, modeling and simulation is very important so that we can know about how the data or how the control flow is going on. So here we are introducing a system or a tool which we can use we can use and we can develop the model and we can simulate through our browser itself. There is no need of installing it in our system. So Insight Maker is the tool which we are going to use, and it is a purely open source software or open source forum which we can do our simulations as well as modeling as well as simulation if we are having an internet connection. Only thing is that we have to create an account in this site. So the advantage of using this Insight Maker is that if we are going for softwares which we have to install in our system, and the portability of that design is very it is not flexible as well comparing this. Here if we are able to create any model, we can get the URL and we can share the URL through any online media. So the portability of the file is very flexible in this forum. And one more thing, this forum, actually this site which work on JavaScript, and since it is JavaScript, whenever we are uploading some design, only at that time only we need the internet connection also. So anyway, it is better than any software which we have to install in our systems. So this is the Insight Maker. So first step we have to do is creating an account in this. So by getting into the sign up option, we can create an account. So after creating the account, we will be getting a window like this. So here there is an option for create new Insight option. So by clicking on this option, we will be getting a new page. There we can model our design. So we can use any type of design procedure. Here we can develop UML, here data flow diagrams, FSM, then control flow diagrams, or any dynamic or any static system can be designed. It can be modeled with its states or its task, and it can be simulated, and all the simulations which we are doing, we can get into a graphical analysis. So the main advantage is that in this simulation we will be getting a graphical interface. In that graphical interface we can analyze all the data and all the transactions or all the state changes. So it is a benefit of using this one. While telling about this software, when we create a new Insight, we'll be getting a page like this. So this is the working area for us. So here we have to model our system. So here there is an option for add primitive. So in primitive we have different primitives. In that, one is stock. So by clicking on the stock, we will be getting that primitive in our work area. So stock is nothing but it's like a bucket. So it can store some data, and that data can be transferred to next primitive. So whenever the data is transferred, normally that stock will be decrementing, and in which primitive that data is flowing, there the stock will be incrementing. So that is the stock. So next one is variable. So as name indicates, it's a variable that we can use in our modeling. Then converters, for different conversion, for height conversions or temperature conversion, for all those things we can use converters. And when we are doing data flow, we will be using stocks And when we have to model any finite state machines, FSM, we will be using state models. So that time we can use state and actions. And this site or this open source tool gives the gives the features like giving text, giving pictures, interactive buttons, everything in our modeling. So that is actually primitive. And after that, next one is flow and transaction. Flows or transactions are the links which shows the flow of data or flow of control. So link is nothing but it's actually data flow itself. Okay. So after creating, we can use these flows for creating respective flows like this, and here we can change the directions also. So by simply clicking on each primitive, we can set the initial settings here. On the right side we can set the initial settings. So here we can give the initial values, and for the flow also we can give the settings, and we can name it here itself. Here also we can name transactions or something like that, trans or something like that. So whatever name we have to give, we can give it here. And the rate also we can give, at what rate it should follow. So here we can give the rate also. And one more thing, in this we can add different functions also. There are so many inbuilt function in this open source tool. So we can add lot of functions like general functions like pulse, step, ramp, extra, and even we can give the conditions also. So programming functions, then in that we have while loop. Also whatever we are having in high level language, all those functions are there. Mathematical functions, rounding up, cosine values, all those things. Even string functions are there, time functions. So whatever, there are different libraries which give different functions. So all these functions can be used for giving initial value or the flow that we need in our modeling. And one more thing, whenever if we are using any state variables, so at that time we have to give the triggering actually. So whenever we have to give the triggering means if I want to go from one state to another, like this, if we want to go means, here I can give the triggering actually at what at what level it should be triggered. For example, I will show one example. So from here I am taking one state. So I am just taking a copy of this state, and I am giving here a transaction. So at this time, here I can give the trigger. So from here I can select timeout, probability of condition. So while doing a finite state machine, we can give the trigger by using these. Either we can give by timeout or probability. So we can give the triggering conditions also in this. And simulation is very easy, that we can directly get the simulation from this simulate. And whenever we press the simulate button, so actually now one error is showing because I didn't set any conditions for all those things. So I'm just deleting this thing. I'm just giving only this one. So after that, when I click on the simulate, it will show the graph actually. So it will show the graph. So whatever we are simulating, everything we will be getting on graph. So we can get the graphical analysis very clearly. So for in the graphical analysis, there is a option for editing all those things. You can give stock display or trans display. You can give the x-axis and y coordinates, everything you can give, and you can select according to that. The selection is here. In this way, fully graphical representation we can get, and we can analyze all the values. A lot of settings are there. We can give it for anytime, means either that graph it will be showing for years, so we can change it to minutes or whatever we want. And most important thing is that this edit, we have the layout diagram, so we can either edit it, we can give it as horizontal or vertical, so whatever we need we can give in the layout diagram also. And in these settings we can give the settings for graphical, and by using the share option we can share the model that we have already created, and if somebody needs our model to be viewed, we can share it them personally and publicly. So overall, this software supports almost all the high level language, looping and conditional statement, and triggering is also possible by using timeout, condition and probability. Normally for FSM we will be using conditional triggering. So data flow can be easily analyzed using this open source tool. So this is the IDE which we are using if we are using for creating our model and simulating, and there is the option for save also, we can save. And one more thing is that wherever we go, we can with a if we have internet connection, we can get this through our account. So the portability is very flexible in this system, in this open source tool. And in this video we will be explaining the basic concepts regarding data flow diagram, FSM and control flow graph. So these three things we will be discussing in this video. So for each one we will be giving you an example and we will simulate it, and how we will analyze how that flow is going on. So next we will be going to different modeling like data flow, FSM and control flow with examples.
Now we are going to see about a simple FSM with simple on-off condition. Just go to add primitive and click the add state. The dialog box will appear, and we need to give one more add state. Just drag and drop option, and here double click on this add state box, and we need to give a name for a state as data on, and the configuration start active is true, and same vice versa for that another state box also. Here I am assuming as data off. The start active condition is false, and here I need to connect from data on to data off by using a simple transmission line. Here we just click on that arrow mark and connect to data off, and here we need to retransmit from data off to data on. Here we give name for start active as data on and data off, and then here we are giving a transmission between both condition of data on and off. And next we are going to arrange in the horizontal manner by just selecting edit option and click layout diagram and click horizontal. Whatever the style you need to give as horizontal layout and vertical layout on organic layout or circle layout. Here I am using as horizontal hierarchical layout. And now we are going to assume a value for the transmission lines. Just double click on the transmission line from data on to data off. Here I am giving the trigger time as 3, and same vice versa value for data off to data on 3. And now I am going to simulate this function. Just click add display and give data off and data on. The legend portion is automatic, or else we can give here x value, minimum and maximum value, and y axis minimum maximum value. This is the output for the simple on off condition. It will take the time period as 3. Here we are giving us same time period for both data off and data on conditions. Time is 3 and data off condition is 0. Here same time and data on is 1.
We are going to see about the data flow. Let us take the following operation here: P2 equal to P1 plus V1 and P2 equal to P1 plus V2. To do this, we have to go to add primitive and we have to insert stock. We have to insert 3 stocks, and the stock function we have already discussed in that introduction part itself. Uh, then this is an 3 stock, and to do the editing part, just click on the stock. We will find that dialog box on the right hand side, which will show all the editing options. Here we can edit the name. I'm going to edit the name as P1 here, and I'm going to give an initial value as 1, and this is an input stock, and these two are the output stocks. Whether I'm going to do the same as I did in the P1, just click on that, and I'm going to give the name as P2 here, and I'm going to give an initial value as 0, and this is P2, sorry, it's P3. In this name we can going to change as P3, and I'm going to do the initial, I'm going to left the initial value as 0 itself. um, just we are going to connect these two stacks. Just go, you will find that arrow mark here, just click on that, and you can able to draw a line from this to P2, and same thing we are going to draw from P1 to P3 like this. And for the regular view, just we can edit these 3 blocks like this. You can go to the layout diagram and do it as an horizontal hierarchical like this. And what we are going to do is we have to add a variable. Just click on add variable, just 2 variables. That I'm going to do the same as I did for a stack. Just click on this, you will find an editing option here. I'm going to give the name as V1, and I'm going to give the value as 3 here, and for V2 I'm going to give a value as 5. Just what I'm going to do is just I'm going to connect this variable to P2 and variable V2 to P3 flow. For this we have to keep the links, and we will find the arrow mark here. Just click on this and you can directly connect to P1 P2 flow, and for this we will find an arrow mark here. Just click on this and we can connect to P2 P1 P3 flow, just like this. And now we are going to do the calculation part. So for do the calculation, we can move the cursor to P1 here, and you will find the arrow mark here like this, and you will find two blocks and one variable here like this. Here we are going to do an following operation, like we are going to add V1 and P1 here for calculation of P2, right? Just click on that P1 here and V1 here. In between we are going to do the addition symbol, just a normal symbol like this, and we are going to give apply. And for the P3 operation, we are going to do the same. We had find that P1, P3 and V2. Just we are going to add P1 and V2 here for P3 operation. P1 and your plus option and V2, right? Just we can apply. Now we can going for simulation. Just click on the simulate and you will find the graph like this. uh, in this, go to add display. You will find the data here. You can select what are the data you want to see in the graph. So I want to see the P1 value, P2 value and P3 value. Just I do all those things. Just click on that and give apply. We will find only three data lines here. What is the initial value we are given for P1 is we are given 1 here, just 1. And for P3 operation we given P1 plus V1, that's added, and you can find that P3 as 6. Like we add an 5 we given in P2 V2, and initial one value P1 were given in 1, so it added and get a value of 6 here. And for P2 we are getting 4. Just we given an V1 value as 3 and P1 value as 1, so we are given then we are getting a value of 4 here. This is the simulation part. We can also given an feedback here. Just go to primitive and we can add stock here, and this stock we are going to given a name as usual. We are going to given a name as something P5, and we are going to give an initial value as 2 here. And for the feedback we can go for flow transition here and click that and click and drag like this, and we have to change the flow, so we are going for this reverse connection direction. Just changed it. Then we have to give a link from P5 to the flow, so I click on links. Then we will find the arrow mark here. Just I'm going to connect to that flow, right? Then what I going to do is just click on shift and click on that right click button, and you will find that arrow mark just changing like this, and you will find the feedback option here. We can simulate as usual, and we can find the feedback, and the feedback will be increase in exponential form. And one more thing, we can also have lots of editing options for blocks and also for variables. Just right click on the stack, and you will find that options like font color change and line color, fill color. Then we can give that uh, name as bold or in italic, or we can add align all those things. We can also having a primitive inbuilt picture, like we can give anything according to our wish for the attractive view.
Let's now check the control flow diagram using Insight Maker. First, creating a stock, and I'm name it as data one. And I'm creating another stock, and I'm giving it as name it as data two. The stock is like a storage device. this data 1 act as a source and data 2 act as its destination. For transferring data from data 1 to data 2, I'm giving a transition. For giving the control, I'm creating an external variable and let name it as var. For giving the control, let's controlling this flow. I'm linking this where using a link. I'm linking this to the flow. Then I'm initializing the values. I'm giving data 1 as value as initial value is 1, and data 2 I'm initial the value as 5. Next, for variable, instead of giving a constant value, I'm giving a slider, so I can adjust the value as I wish. Then I'm going to give the control for the operation. Once again, I'm giving the control. Selecting general functions, I'm giving the if else statement. For the controlling, I'm giving if then else statement. I'm giving the condition as variable. Let it be greater than 10. The value if true, that's if. If it is true, then I'm giving the statement as data 1 plus data 2, and if it is false, I'm giving as data 1 minus data 2, and again applying this. I'm giving now value as some value that's less than 10. Then I'm stimulating this, and now we can see a diagram. We can see the graph, which is actually for something less than 10. Now we can check what will happen if it is greater than 10. Again, we can see the difference, as I given as for greater than 10, it is actually data 1 plus data 2. That's here is showing there's a difference. It's actually adding up the data. So this is a small example for control flow diagram. As actually we can use with this Insight Maker. Insight Maker is a powerful simulation tool that runs into the web browser. First of all, it is completely free. It's an online simulation tool anyone can use without any cost. It also support many features, so many features that can be supported by Insight Maker. Insight Maker can be used to start a building model and then convert it into a complete simulation model. The Insight Maker supports extensive diagramming and modeling features that enable us to easily create the representation of any system. Some of the features that support by Insight Maker is was system dynamic modeling. So some of examples are causal loop diagrams, then stock flow diagram, etc. Then other is diagramming and rich pictures. There is extensive styling features, custom and built-in libraries of pictures, folding and unfolding of portions of diagram. Then it also supports run modes that supports powerful simulation method that rival many commercial programs help to use system dynamic modeling. Some of them are time series and scattering plots or phase plots, maps and network diagram, table data export, time nature analysis. Then it also support function and programming. Some of them are large library of built-in function, user created macros and functions, procedure programming, function programming. It also supports some simulation algorithm. The algorithms such as Euler's method, fourth order Renchikuta method, etc. Here we are more interested in its features as stack and flow model and state and transition diagram. So little bit explain deeply into both of them. First, stock and flow model is graphical. One of them is graphical inputs. That is, we can add graphical inputs. It can add structural input or empirical data to the system, assessing historical perceptual data recording periodically. Next is ghosting primitives. Ghosting is one tool that can be used to compact the graphical complexity and to keep even the most complex model straightforward. In short, ghosting allows you to make a reference to or a ghosting of primitives to your model. Next, vector primitives. Using this to easily extend a model to represent different categories or class of behavior. Next, we can look under status and transition diagram. There is custom action. First is custom action. The action can be used to manipulate a model during a simulation. Actions are primarily used in agent-based modeling. Here, two type of features are there. First is by triggering. Second is by action. By triggering means when triggered, the action occurs. Next is action. That is, action is specific here. Action specific means that a particular action, actually user specify the which action to be triggered. More importance is given for the specific action. Next under this is a spatial relationship. Insight Maker in each agent population can be given dimensions in terms of a width and a height. By default, agents are placed at a random location within this region. Some of the placements are random. That is, agents are located at randomly arranged. Next, grids. As agents are placed as the form of grid. Next, ellipse. Agents can be arranged as a elliptical region. Then network, it can be as agents can be arranged as a form of a network. Next one of the features under stack and transition diagram is network relationship. To create connections and remove connection between agents, You can use the connection and unconnection function. Both of these functions take one argument, the agents that should be connected or disconnected.
Now let us see an example. It's integration of both data and control flow diagram. Uh, this is a project about global warming. Mm, It mainly consists of three loops: R1, R2, and R3. Your R1 shows the ice cover of ocean melts and shrinks. Less sunlight is reflected back into space, and so more is absorbed by ocean itself, and more warming as its consequence happen. This warmer water and warmer air temperature will then melt more ice, but it will also break up more methane hydrates. Then here the loop R2 illustrates a process whereby frozen methane hydrate, which exists in enormous quantities on the seabed of the shallow Arctic Ocean shelf, is breaking up as the ocean warms. Uh, this leads to methane gas, a greenhouse gas about 20 times more powerful than CO2 bubbling up to the surface. Then the loop R3 describes a similar process where melting of permafrost releases methane into the atmosphere, making the situation even worse. These processes are multiplicative. They reinforce each other. These are the three loops. Now let us check the diagram. Here, let us see the temperature of Arctic Ocean. As a due to this temperature, the melting of polar ice sheet is happening. Due to this melting, the ice cover is reducing. Because of this ice cover reducing, this again happening to the reflection of sunlight. This will reduce the reflection of sunlight back into space as the ice cover is more and more decreasing. Less reflection happening. Due to this less reflection, more absorption of sunlight by water is happening. Due to this more absorption of sunlight, the warmer the temperature of this ocean water is again increasing. This again cause the increasing of temperature. This is actually happening in the first loop, which that is exponentially. This decreasing sea ice. Next, we can check the loop R2, that is exponentially increasing methane release ocean. As due to the temperature, the melting of methane hydrate on seabed is happening. Uh, Due to this melting, release of methane into atmosphere. As methane is released into atmosphere, this causes an enormous amount of increase of temperature. This will cause melting of polar sheet. Again, due to this melting of polar sheet, the ice cover is reducing. Due to this reflection of sunlight is into space is reducing. Again, this causes more temperature of ocean water is increasing. So this actually happening as a loop. So again, uh, what again the polar ice is melting. Next, we can check the exponential increasing of methane release tundra in R3 loop. As the temperature of Arctic, due to the temperature in the Arctic Ocean, the degradation of permafrost of land. This also the degradation can be also caused by Arctic air temperature. This both cause the decay of organic matter. As is decay of organic matter, again led to the release of methane into atmosphere. This increase as methane increase the temperature. Again, the melting of polar ice cover due to the reflection of the due to the degrees of the ice cover, the reflection of the sunlight into the space again decreases, and the temperature is again increased. As this is happening as a part of cycle, the global warming it causes a global warming, uh, and the temperature of the surface, the earth, is increasing, anomaly increasing, and the water level, sea level is also anomaly increasing. Uh, these these are accelerated global warming.